So we're going to go through the review for the final exam for our Math 146 course, and this aligns with the printable version that I sent to the students in my class. So you'll be able to match up the answer that I get with the answer on paper. If you do it online, you'll have your own one to practice, which will likely come up with a different answer due to different numbers being in place. How many ways can 4 different printers be set on a shelf? Well, that's 4 in the first, but now not 4, 3 on the next, and so forth down. That's going to create a situation where you have 4 factorial. 4 times 3 times 2 times 1. That's going to get me 12 times 2 for 24 times 1, and there's 24 ways you can line those up. You don't have to list all 24 ways, but you need to know that this is a factorial and get you 24 ways. The network places 13 shows in 7 openings. How many ways can they do this? Each opening is different. I've told several people throughout the semester that not every slot in a network schedule is worth the same amount. So those are distinct. They are different slots that we're doing this. So then what we're doing here is we're doing 13 P7. And you need to evaluate that with whatever technology you have available to you. Now 13 P7, if we did it the old-fashioned way, we would have 13 there, and then we would have 13 minus 7 here. And that alone would be combinations, but we're actually doing permutations, so the 7 factorial shows up here also. 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial. And this will be my 7 factorial. The other one is 6 factorial. 6, 5, 4, 3, 2, 1. The 7 factorials go out in their entireties. And now if I want to take out the 8, I'll drag out the 4 and the 2 and get the 8 to be 1. If I want to take out the 9, I'll take this out to 1 and make that a 3. Take the 6 down to 2 and make that a 1. And how about if I take the 5 times 2 out, 5 out, divide by 5, divide by 5, that's a 2, that's a 1, divide by 2, divide by 2. It appears to me that I'm going to have here 13 times 12 times 11 is what this one works out to. So if I was doing it the way I did back in the 1980s, I would be working on this. And let's see if I get adequate lighting here to fire up the solar lit. 13 times 12 times 11. 1,716. Let's see. 13 times, oh, nope, strike that. That's combinations. So this is what we would have done if we had the combinations, and it's not a combination. Good opportunity for me to continue with the rolling on this, saying, you know what, that was wrong, not terribly wrong. What happened here was I did decide that it was going to be 13 P7, it's a permutation, but I inadvertently applied the combination formula. This should only be 13 factorial over 13 minus 7 factorial. It's going to leave a lot of them here. 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial. I grabbed the wrong formula, which now is corrected by grabbing the correct formula, this one. One of the biggest keys is recognizing whether or not this is a permutation or combination. I did that right. I said this is a permutation. I put up the P, and then I went to the wrong formula. The formula for combination would drop it way further down. This is going to get me 13 times 12 times 11 all the way down until I reach the 8. So if I had that, 13 times 12 times 11 times 10 times 9 times 8. I'm going to have, let's see, 13 times 12 times 11 times 10 times 9 times 8 equals what? All right, I'm getting, let me just try 13. I think this calculator has factorials on it. Am I wrong? No, it does. 13 factorial divided by 6 factorial. 8648640. Placing these properly over 8 million ways. 8,648,640. That's what we're getting from that outcome. And that's a lot of choices. The other one, I had a much smaller number. If it had been the combination, what's the difference between permutation and combination? That's really what we're looking to have you recognize. If I said a group of 7 shows are chosen from 13 shows to be put on the air, that would be a combination, which would be a group of 7 shows, all of them being treated equally, or the 7 slots, if you want to say, are all treated equally because you are in all 7 the same. This is not that. This is a first place, second place, third place, all the way down to 7th place. And from 13 shows, we get these. And so that's a permutation. Probability, when we roll a die, there's one die and it's got these possibilities. 1, 2, 3, 4, 5, or 6 facing skyward. The probability that the roll is a 3. There's only one of them that is a 3 out of all 6 rolls, 1/6. Probability that it's an odd number. The 1, the 3, and the 5. That's 3 out of 6. Perfectly fine. Also known as half. Most people leave me 3/6. It'll show that you knew there were 6 and that there were 3, and I'm not testing you on your ability to reduce the fractions, but half is also acceptable. Probability that the number is greater than 1, such as the 2, 3, 4, 5, and 6. All 5, except for the number 1, out of 6, are greater than 1. It doesn't say greater than or equal to 1, it says greater than 1. Probability that the number is less than 7. This 1, 2, 3, 4, 5, 6, all 6 of them are less than 7. So if I go 6/6, I'll actually see that the probability of that is 1. And I much prefer to do that and have you give me the probability of 1 than say, what's the probability of something that's certain to happen, and expect you to bring it out of that question. Rather put it in play here, and if it's a guaranteed to happen situation, probability is 1. Probability that the number is greater than 3 and odd. So I'll go through this as my last one, greater than 3. I'll put a box around each one that's greater than 3. Whoops, say you're out. 3 is not greater than 3. 3 equals 3. 4, 5, and 6. So they are still in play for this other one that says they also need to be odd. I will circle the ones that are odd. And now I'm looking for ones that are squared and circled, and that's only the 5. So this is 1/6. Because and means you need both. Another possibility is this one could have said or, which means you have at least a square or a circle around your number. And that would have been 5/6 for or, but it's 1/6 in this situation for and. Okay, continuing with the review. Class contains 4 women and 3 men. What's the probability that the randomly chosen member of the class is a man? Let's set up the sample space. 1, 2, 3, 4 women, 1, 2, 3 men. And so we have 1, 2, 3 men that do meet our criteria, which is 3, over the total of 7, probability 3/7. People responded to the statement that Wall Street workers were as honest as other people with this. They agreed 701 times, disagreed 161 times, and were not sure 92 times. The problem as written on the review also said that there were a total of 954 people making these decisions. So what's the probability that someone thinks that they are less honest than other people? Out of 954, we're going for the people who disagree that they're as honest. Disagreeing that they were as honest is to say that they are less honest. And therefore, we're going to put 161 on here and pass that as our probability. Either agrees or disagrees, which is this 701 or the 176. We add those two together. We get 862 out of a 954. And it's not your job to fully reduce the fraction. You certainly could, but those will show me that you know how to handle those kinds of problems. Number 7, Shayna is looking at an iPod, and she liked 11 songs, disliked 9, and had not heard 4. Find the probability that she liked or disliked. Either one of those were possible of the songs. So she's got 11 and 9 for 20 plus 4 for 24 songs. So Shayna's taking a look at one of 24 songs. That she liked or disliked is 11 plus 9, but it does leave out the 4 songs that she'd never heard before, which will get us 20 out of 24. That could be reduced by dividing by 4s and get me 5 out of 6, but 20 over 24 will do the job to demonstrate mastery of this concept of probability. Question 6 had been eliminated. We decided not to use it, and it will not be on the final question 6 on the review. Okay, on.
Oh, I got it. Yeah.
So when we go to the deck of cards or the 2 dice, on the written final exam, the packet would have included the sample space for the rolling of 2 dice or the drawing of cards from a 52 card deck. And you're allowed to use that as well. You may have the one that I gave you, you may have the one that you print from the internet, or you may have one that you get from the book. Anywhere you want to go for it, you can also pull out a deck of cards and use that. You pull out 2 dice if you want to do that, but the sample space is a key to getting through this. If we have a 9 or a heart, there are 52 cards in the deck. So we have the possibilities of, when we look at the sample space, there are 4 9s in the deck. And as far as the hearts go, there are 13 hearts in the deck. We do have to subtract the card that gets double counted. That is the one card that is both a 9 and a heart, commonly known as the 9 of hearts. So this will get you 52 on the bottom, and when you add 4 and 13, you get 17 minus 1, you get 16 out of 52, which is fine. If you divide both by 4, you'll find that it's 4 over 13, which has no real relevance. It's just a reduced fraction. When we're looking for a king or a red card, we'll find the following. There are 4 kings among the 52 cards. Plus red cards, there are actually 26. All the spades and all the diamonds are red cards. Now, there are 2 red kings. There's a red king that is a heart, and there's a red king that's a diamond. So we have to subtract from here the 2 over 52. This gets me 30 minus 2, which gets me 28 over 52. And again, you can use the sample space, have it available. It's completely legal. If you divide top and bottom by 4, you'll find another not particularly relevant 7 over 13, but 28 of the cards will meet at least one of the criteria. So now, an item is being chosen at random from these items, which are by Kenneth Cole, Michael Kors, or Vera Wang, and they are also designated each time as being one of the dresses or jeans. And now it says, let's find out what are the probabilities that you'll find something from Kenneth Cole or a dress. Now, when I go for this, I found out there were 40. When I go for this, I find out there were 60. And when I go for this total, I'll see there are 36, which sets me up to get 136 total. 136. Which would be the denominator of each of my fractions as I set them up initially. From Kenneth Cole or a dress. So with Kenneth Cole, I have 40. I also have other dresses, right? I have 40 and 26 and 20. Or I can get all of Kenneth Cole at 40 plus all the dresses, which in this case will get me 41, 61. And if I go here, I got 59, 69, 75. So if I go for all of the Kenneth Cole 40, and then I say, let's count all the dresses as 61, some of the dresses were by Kenneth Cole. I need to subtract Kenneth Cole's dresses as 15. So 101 minus 15, 86 over 36. Well, 86 over 136, all right, that reduces, but this is where we're really looking at what we have. We have 101 minus 15. Jeans or from Kenneth Cole. So we begin with all the jeans. The jeans are 75. Kenneth Cole tries to bring 40 items to the table, so 75 plus 40. 75 total jeans, and then total, it looks like we got 40, but among the jeans we had Kenneth Cole's jeans. Those 25 were already on the table. It's Kenneth Cole, so I got to subtract 25. And we'll see 75, 115, and then take it off. We'll get 90 over 136. Okay, you can reduce that fraction, but that's what's looking to show me that you know how many of them qualify to meet at least one of these criteria. Michael Kors or Vera Wang, right? Michael Kors or Vera Wang. 60 Michael Kors and 36 Vera Wang. And what happens here, if you're a Michael Kors creation, you can't be a Vera Wang creation. If you're Vera Wang, you can't be Michael Kors. They have no overlap. This gets to stand simply as the 96 over 136. You might reduce that fraction as well. But there was no situation where some of the clothing was created by Michael Kors and at the same time created by Vera Wang. These were no, combined efforts. Now we would go to the 36 rolls that could come from us rolling 2 dice, and you'd have a sample space available to you that you can certainly look at. And what we would find out is when we look at the 36, if we looked at all of the 6s, then we can have 6s that are like this: 1 5 2 3 3 2, and let's see, what was it? 1 5, sorry, 1 5, right? 2 4 3 3 4 2 5 1. There are 5 of those. Plus 7s. 1 6 2 5 3 4 4 3 5 2, and another one 6 1. We got 6 of those. Plus, and now for the 8s, we can't have an 8 that has a 1 in it. So now we're going to have 2 6 3 5 4 4 5 3 and 6 2. You got 5 of those. 16 out of 36. That reduces. If we divide each one by 4, we'll find that it reduces to 4 over 9. But there is nothing that's at the same time being a 6 as being an 8 or any of those that overlap. Now we get into some overlaps. For the 4s, first thing we see is we can get a 4, and that's going to be 1 3 2 2 or 3 1. We got 3 ways to make a 4. 36 total. A 6, we can have 1 5 2 4 3 3 4 2 and 5 1. We got 5 ways to make that. And then doubles: 1 1 2 2 3 3 4 4 5 5 6 6. 6 of those. But the double 2 was a 4. The double 3 was a 6. Those have already been counted, so we do have to subtract 2 off of there. So we get 8 14 minus 2. We get 12 out of 36. Reduces to 1/3, but 12 out of 36 will show full mastery. You did have to say that I cannot count the 2 2 as both a 4 and doubles. It's one of those two, but not both. I cannot count the 3 3 as a 6 and doubles. Greater than 10. So that's both of the 11s and the 12. There's 3 ways to be greater than 10. It's all out of 36. Less than 4. That's 1 1, 1 2, and 2 1. And that's it. There's 3 of those. And we get 6 ways to make 7. 1 6 2 3. 1 6 2 5 3 4 4 3 5 2, and finally 6 1. 12 out of 36. Also 1/3. Right. Okay, these are 4 measures of central tendency that we're going to look for. The first one is the mean. Here's our data set made up of 1 2 3 4 5 6 7 8 9 values. We will add them up: 16 and 11 for 27, 3 more for 30, 16 more for 46, 9 more for 55, 7 more for 62, 13 makes 75, 80, 96. So the sum of all the scores is 96. We need to divide that by 9. That equals, when we approximately go through there, we're going to get 10.666, and that's going to get us right around 10.6. I believe it asks us to round to a single decimal place, making sure. Oh, 10.666, yeah, it is 1 decimal place. So we'll look at 10.66, which looks more like 10.70 and get us 10.7. 10.66 rounds up to 10.7. The median requires these to be put in order. So as we put these in order, the lowest one I have is a 3. As I look next, I get a 5 and a 7. So that's done That's done, that's done. Then a 9. 4 places at 9. No 10, we got 11 is in the 5th, and 13 is in the 6th, and then I appear to have 3 16s to wrap it up. So for the median, I need to find the average of 1 plus 9 to get me 10 over 2. I need the 5th place. 1, 2, 3, 4, 5. The median is 11. The mid-range extremes are 3 and 16. So if I take 3 and 16, I average them. I get 19 over 2 for 9.5. And the mode is the one that occurs the most frequently. It's easiest to tell the 16s are there all together. The mode, there is a single mode, and it is 16. A data set has a mean of 80 and a standard deviation of 7. N is the 190 values. How many of these values lie between 66 and 94? So I begin here looking at what's going to come out on my normal curve using the empirical rule, which is, we got plus and minus 1, plus or minus 2, plus or minus 3. And here we go. Our first placement is put the 80 in the middle. Then let's go up or down by 7. We're looking to reach 94. So when we go 7 more, we're at 87. We're not there yet. 7 more puts me at 94. That's plus 1, that's plus 2. 0 is right in the middle. I also have to be subtracting them to get lower than 80. So if I go 80 minus 7, come out of here with 73. That's not it. 73 minus 7 more will get me 66. Perfect. That's negative 1. That's negative 2. I'm looking here at plus or minus 2. That's 95%. Therefore, I'm going to go with 0.95 times my 190 and give it a rounded value to 1 decimal. So I got 190 times 0.95 for its 95%. 180, let's see, 0.5. This is testing the empirical rule, which you're allowed to have on your note card in your notes. That'll tell you, 66, 95, 99.7, 1, 2, 3 ripples out from the mean. That's use of the empirical rule. If a normal distribution has a mean of 62 and a standard deviation of 20, find the z-score of 55. So I'm going to place my 55 in here, and I'm going to center it by subtracting the mean. Then I'm going to take that whole thing and divide by the standard deviation. That's what the z-score has us doing. This will get me negative 7 over 20 for negative 0.35. This is negative 0.35. So the standard deviation, I don't write negative 0.35, I only write 0.35 here. Standard deviations, because it's negative, I have a value below the mean by that many standard deviations. The z-score counts standard deviations, even if it does so with a decimal. This one I should have a little more information. This is circle A, and this is B. And as we're looking at 14, I need to know anything in circle B. So circle B does have this 6 and that 11, they're part of circle B, even though they're in the football. And 14 and 16 are only in circle B. So I get 6, 11, 14, 16. Now I was looking for anything in any way enclosed by the fence for circle B. So number 15 has this Venn diagram, and it says A, the upside down UB, that's A and B. So it's only going to be looking for something that is in both A and B. And so if it's in A, I have options of 1, 3, 5, and 6. If it's also in B, then it's only these two, and that's going to give me 3 and 6. A union B, or A or B, is in at least one of A or B. So I'm going to go through them in order. Number 1, is it in A or in B? No, and it's got to be at least 1. Is 2 in at least 1? It's actually in 2, but it's fine. Is 3 in at least 1? No. Is 4 in 1? Yes, for B. Is 5 in 1? Yes, also for being in B. Is 6 in one of them? Yes, 6 is only in A, but that's enough. 7 is in A, that's enough. 8 is in B, which is enough. 9 is in both, which is more than at least 1, but is at least 1. It's not just 1. So even though 2 and 9 are in both of them, they are in at least 1. And so the only two of those that range from 1 through 9 that are not included are 1 and 3. Finally, this says the complement of A. I want what's outside of A. So anything that's not in A. So clearly 6 is not in A, but 2, 5, and 7 also are not in A. They are in B, but they're not in A, and this is all about are you in A or not. So what's outside of A? 2, 5, 6, and 7. We want to negate the statement that says, don't worry, your computer doesn't have a virus. So don't worry is a warning. It's not got anything to do about the reality, because what we want to do is we want to say it is false that, and then go with this and then simplify the expression. Don't worry, your computer doesn't have a virus. It is false that don't worry, your computer doesn't have a virus. Let's get rid of don't worry. It is false that your computer does not have a virus. Let's see, false is a reversing word. Not is a reversing word. And so what we have is two negatives. It's like -1 times -1 about you having a virus. If it just said your computer doesn't have a virus, it would be negative to you having a virus. But it's the opposite of negative, you're having a virus. So this is like 1 virus. Yes, your computer has a virus. So we're going to look for the options. There are 4 there, one of which is stating that your computer does have a virus. Bam, right out of the box. A, your computer has a virus. I should check the other 3, make sure none of them also seems to say that your computer has a virus. It is not true that your computer has a virus, so B is not our goal. It is true that your computer doesn't have a virus, also not saying the same thing. Don't worry, your computer doesn't have a virus. None of those are good, only A. This is going to be choice A. Your computer does have a virus. It's false that your computer does not have a virus, so your computer does have a virus. Okay, we're going to do number 19. I've set up the standard order for true and false values for P and Q. And the first thing we do is we go through and we fill in the values of P and Q right underneath them. So P and Q. P is going to be TTFF. And Q is going to be TF, TF. Make sure that I can see, it won't be a problem on the computer, but make sure you can see which one you mean to put in, because you're clearly going to be selecting that on the computer before you submit this choice. Anytime that I can immediately take a negation, I need to do it, and I can do that for this P. So I'm going to reverse T to F, reverse T to F, reverse F to T, reverse F to T, and these are going to be gone. Now I'm going to finish this one. That was my second step, my second wave through, and now I'm going to do an AND of the surviving values. Are they both true? That's what AND means. FT, are they both true? No, so that's false. FF, are they both true? No. TT, are they both true? Yes, that's getting a T. TF, are they both true? No. So I will take these out and leave my answer column to be in order FFTF. Let's check that was number 19, that it will hit FFTF. Number 20 is using the same values of T and F in the same order. We now have 3 places where we have to insert values of P here, values of Q here, values of P here. Every time we have P, it's TTFF. TTFF. Q is TFTF. P is TTFF. Is there anywhere where I can immediately take the negation? Yes, right there, that negation of P. Second step, negate the value. Reverse T to F, reverse T to F, reverse F to T, reverse F to T. Take all of these out. Now, I have a pair of parentheses here that I must do. I don't have a single value to use the implies arrow with yet, so it's time for me to go ahead and do OR. OR means at least one true. I need to get at least one true. So I look at T, and T as well as T is at least one true, yes. T as well as F is at least one true, yes. F as well as T is at least one T, yes. F as well as F is at least one T, no. So that gets a false on the bottom line. Now you need to deal with what you learned, the way that we deal with the umbrella, keeping you dry, then not getting arrested for blowing a stop sign. But here we go. I will do this with the umbrella, then I'll do it with the stop sign. One of those should be yours, or you need to know how to deal with implies. The only thing that's going to be false is if it's true, implying false. It's true we're supposed to do it, and false that we do. Such as this. We'll ask about the umbrella. Do you stay dry? Let's see. It says that if it's raining, then you need an umbrella, right? That's what we got. So this here is going to be about whether it's raining. This is going to be about whether you brought an umbrella. Okay. It's truly raining. You did not bring an umbrella. Did you stay dry? Nope. It's truly raining. You did not bring an umbrella. Did you stay dry? Nope. It's truly raining. You brought an umbrella. Did you stay dry? Yes. It's not raining. I don't need to continue, but I can. It's not raining. You happen to have an umbrella anyway. Did you stay dry? Yes. FFTT. Let's see how they went last time we did this. Yeah. You want to do that one with the stop sign? The only way you can get in trouble with the stop sign is by blowing through a stop sign. And I will ask, did you stay out of trouble? It's true there's a stop sign, it's false you stopped. Did you stay out of trouble? Nope. It's true there's a stop sign, it's false that you stopped. Did you stay out of trouble? Nope. It's true there's a stop sign, you did stop. Did you stay out of trouble? Yes. There's no stop sign, so you can't even get in trouble. But there's no stop sign, you stopped anyway. Did you get in trouble? No. And you did not get in trouble. So did you stay out of trouble? Yes. We got the T right there. All right. These are times of day. All the ones that are below the line. The ones above the line are how many people voted for that. So how many people voted all together? 8 plus 12 for 20. 20 plus 5 for 25. 25 plus 3 for 28. 28 plus 2 for 30. 30 plus 2, 32 people. Who got the most first place votes? We see that 8 o'clock got some first place votes here. Got those 8 as well as those 2. 8 plus 2. 10 votes. 2 o'clock got these 12 and those 2. So 2 o'clock got 12 votes in one category and 2 in another. 14. 10 o'clock got these 5 and nothing else. So 8, 2, 10. Here's where noon gets its votes. 3. Which of the times? 8 with 10 votes, 2 with 14 votes, 10 a.m. with 5 votes, or noon with 3 votes? The winner is going to be 2 p.m. That 12 votes, it doesn't. That's what we had 14 votes. It doesn't ask for that, but we did want to see who had the most votes by plurality. There we have it. Okay, we have 3 districts, and they're going to have seats assigned to them. There are 7 seats to be assigned among the 3 districts. We're going to use Hamilton's method, and we're going to go through the process of A through D to get these seats assigned. Number 1, find the standard divisor. We have 565 is the number of people that we're accounting to spread out these seats among. So we take our 565 and we divide that thing by 7. Let's look for how it's asking for the decimal of this. It's suggesting that we go for 3 decimal places. So I did that division. Oopsie. And what I had was the 565 divided by 7 got me 80.7142 to be 80.714. My standard divisor. Find each district's standard quota. So we're going to divide each one of their populations by that quota, and we're going to go again for decimal places. We're going to go for a total of 3 decimal places each to make sure that they do break the tie. That might occur with no decimal places, or maybe even 1 or 2. 144. 144 divided by 80.714. 1.7840. And that will become 1.784. The next one is going to be taking 245. Divide by that same 80.714, 80.714 equals 3.0354, 3.0354. And so the 54 is more like 50 than 60, 3.035. And clear. And finally 176. 176 divided by 80.714. 2.1805. And so now we're going to take those and we're going to find each lower and upper quota. Take this down, so it's going to be a 1. Take it up, so it'll be 2. Second one, take it down, so it's just 3. Take it up, it would be 4. And that one, take it down, so it's just 2. And take it up, so it would be 3. Lowers would get us a total of 6. Uppers will get us a total of 9. We need a total of 7. This is where Hamilton's method comes in. And we would look and we would see that this number has 0.78, this has 0.03, this has 0.18. The decimal term, the decimal digits determine who's closest to getting allocated another seat. So we're looking at a 78, a 3, or an 18. And this one wins. So what happens is this one gets to go to its upper limit. And now we have 2 and 3 and 2, which gets us 7. So that's going to finish our work. These guys are going to stay with their lower limits because they didn't come close enough to earning that extra seat. So in order, it'll be 2, 3, and 2. What's important to understand about Hamilton's method, it didn't just go to that because 7 rounds up and 0.0 rounds down and 0.1 rounds down. If we somehow found similar numbers and we had 2 seats to give away, that wouldn't happen just by setting this at 8. But if it did, if we had 2 seats to give away, then this would take up its seat and would be out of the running for the other one. And these two would go to battle where the 0.03 and the 0.18 would get a seat going to the 0.18. So it's not because they round up or down based on whether they're above or below, 0.5, but rather we distribute them based on the decimal remainder until all the seats are gone. And that's what Hamilton's method does. I had initially written this wrong on the board. I had that written as quarterly, and I did the problem out on my own, and I found out it didn't get the answer we needed to get for our printed version. This should be monthly, so we're going to run it monthly and get the right answer this time. What we see is the Bartons need to save $80,000 over 13 years. Their fund pays 6.2% APR compounded monthly. How much should they put into the fund now? It's not an annuity. It doesn't talk about payments going in over and over. There's a one-time money drop, a pretty significant amount of money going in. They're going to go back and get a lot more money to come out with $80,000 in 13 years. This is compound interest, but it's not an annuity. And therefore, the formula that we're going to go with is the account balance is equal to your principal times 1 plus R to the power n. And so now when we look here for A, they actually do know what they need the account to be worth. The future value of the account is $80,000. We don't know P, that's what they're asking about. How much to put in there? What should the principal be? What should they put in the account of their own money right now? So we don't know P, but we do know R. It's based on 6.2. Divide by 100. And then divide by 12 because it's monthly. N is equal to 13 years, but not just once a year. 12 times a year, 13 times 12, get you 156. Let's see what happens with R here. 6.2, divide by 100, and then divide by 12. That runs off screen. So we're going to need to enter the 6.02, the 6.2 divide by 100, divide by 12 when it's time for the interest rate to go in. What happens though is we take our account balance is equal to P times 1 plus R to the n, and we're going to divide both sides by the parentheses, 1 plus R to the power n. Parentheses 1 plus R to the power n. Taking out these each to leave me with A equaling P over 1 plus R to the power of capital N. P is $80,000. What I need to get down here is 1 plus 6.2, divide by 100, and divide by 12. That will get me a good factor to work with using the excess memory that the calculator has to get as much accuracy as possible. Take that up to the power 156. So we'll go with our calculator here. The 80,000 can stay for this step. But when I go ahead and use my parentheses, etc. for the bottom, I'm going to open up a pair of parentheses. I'm going to go 1 plus 6.2, divide by 100 for percent, divide by 12 for my months per year. I'll then close the parentheses, and I don't write this, but it's 1.0051666667, and I want to raise that to the power of 156. And that gets me what the denominator is approximately equal to, but I don't clear it on my calculator. I don't think that's something to do yet. 2.23429,329. Now you can clear it if you want to do that. But what I'm going to do is 80,000 divided by what my calculator knows. So when I come around and see what that makes for me, it makes me 35805. For now, I'll write 3 decimals. Let me get back in the light here. The decimals say 0.505. So I'm going to have that round off to $35,805.51. That's what they put in the one time right now. Go back and they'll have 80,000 13 years from now. So we have in question 24, business saving money for 2 years. They're putting money into an account, $2,750 into the account quarterly. So 4 times a year they're going to put that in. That's just a little over $10,000 per year, so a little over $20,000 of their own money. They earn compound interest quarterly at 6%. What's the future value of the account? So we'll go ahead and see what happens here. We have to decide what's going on. Are they saving money or are they borrowing money? It turns out they're saving money. It even says so right there. Is it compound interest? It is, but is this compound interest dropping money in once and then applying compound interest with the same factor over and over again? Or is this multiple deposits? This is multiple equal deposits of $2,750. You might recognize it as an annuity, but I took the word annuity out of the wording here because I want you to be familiar with the idea that an annuity is multiple deposits of the same amount. So we're looking at what's going on here. 6% is going to be good for the help me get to the rate. 2 years will help me find how long it's in there. But this is $2,750. They're paying that quarterly. So is that what they're trying to get up to, or is that what they're dropping in? And it turns out that's what they're dropping in. So P is equal to $2,750. That's their principal if they were doing compound interest, but it's their payment because they're doing it multiple times. Still, it's P and it's their own money. So I'm going to go for R. Quarterly R. Right, R is 6%, so we're going to take 6, divide by 100 for percent, and then quarterly tells me to divide by 4. N is going to be only 2 years, but it's going to be 4 times per year, so 4 times 2, not a big number, but still, they're going to make 8 deposits. This 6, divide by 100, divide by 4. And deal with our percent and our quarterly interest rate. We'll take 6 and divide by 100, then divide by 4, and get that to come out to 0.015. So we're going to have that the account balance is equal to the payment times 1 plus R to the N, then minus 1, and that all goes over R. Now the R is capital R, right? Remember, it's up to you if you use the other formula to deal with all the nuance that comes from having the lowercase n and t and r and all that. But here's what we've been working with. We're going to put in there the P is valued at $2,750. In here, we're going to have 1 plus R is going to be able to go straight to 1.015. And that's going to be able to be raised up to the power. Now the power is 8 because it's quarterly for 2 years. and then minus 1 in those parentheses. Down here, 0.015. So up top, we've got 2,750 times, I'll open up parentheses to put in the 1.015, which I will power up to 8. Then I'll subtract 1 before I close my parentheses. And then I will go ahead, and the parentheses are done, it's ready to do the multiplying. I'll divide by 0.015 and come out of here with 23190. Now I had said earlier, 23190.307. That's $23,190.31. And what had happened is they paid this amount in 8 times. So if I take 2,750 times 8, you'll see that 22,000 of that is their own money. There was some interest gained, but they weren't in very long. And that's where they wind up with the $23,190.31. Now, when we look at the next problem, it may be similar, but it's not exactly the same problem. And it's not just a matter of the numbers changing. A company needs to save $130,000 by making monthly deposits to an account earning 10% APR compounded monthly. What is the amount of their monthly payment? So it's the same function. They're putting money in over time. They're doing it every month. They're doing it for however long they have to say it serves by making deposits account. Doesn't say how long they're doing it, so this is an unsolvable problem unless they say how long they're going to do it. I'm sure the written problem has it. 11 years. Say make monthly deposits for 11 years into an account earning 10% APR. Okay, now we've got all the information that we need. And the problem that you'd see on the worksheet or on the exam would include the number of years. So in this case, A is the amount they want to get up to, $130,000. They're not putting $130,000 in every month for 11 years because they'd have plenty of money if they did that. They're trying to get there. So we're looking for P, and we're going to find R. It's going to start as 10, divide by 100, and then divide by 12. And N is the number of payments or periods that they're going to have. It starts as 11 years, but then they do it 12 times a year. So that's going to be 132 payments. When we try 10 divided by 100 divided by 12, we do get a decimal that doesn't terminate. 10 divided by 100 and divide by 12. Come on, sunlight. 10 divided by 100 and divide by 12. Yeah, that doesn't terminate, which means I'm going to have to write it up there as I need it. Now what we have here is we're looking for P. So P is going to have the same relationship, but the formula will be written differently as it isolates the P. It's going to have A times R over the parentheses with 1 plus R to the power N and then minus 1, and that gets closed in. So let's see what happens when we multiply A times R. A is 130,000. And then we have to multiply by all of these 10, divide by 100, divide by 12. So 130, 1, 2, 3 for 1,000, times 10, divide by 100, and then divide by 12 equals. Looks like it's 1083, and then as many 3s as you can handle. So that doesn't really terminate. And now I got to do the denominator as well. For the denominator, I need to open up a pair of parentheses and put in 1 plus 10 divide by 100 and divide by 12, which I can then close my parentheses and raise that to the power of 132. Before I'm done with that, I have to subtract 1. Pretty much to 1.990504,108. How do I know whether I could put 2 in or not? Well, I'm not going to risk it. I'm going to put in 1083.3s all the way I can and divide by what that has. So 83. Give it all the 3's it can handle. And let's see what it gets. Where's that button for me? There you go. 544.25. So those are the payments, a little over, close to $550 per month. It was 0.250, and it's going to get me there. Now let's see what would have happened if I didn't use all those digits. What if I did 1083.333333, and I said, let's just divide that thing by 2. Be 541.67, and it would be wrong. It wouldn't be the nearest penny. So we do have to take it as far as we can and then round it at the end. So good evidence of that. But that's where that one winds up. Let's take a look against the answer that we have on our key. Yeah. All right. 5. We're facing a problem here where stores purchased for $646,000. That's the agreed upon price. There's a 6% down payment made on the loan, and the balance was financed at 6.9% APR for 24 years. Find the monthly payment, and there they mention monthly, so the payment will be monthly, so the interest will be applied monthly. What's going on here? Is someone saving money or is someone borrowing money? And here's the big change. This is someone borrowing money. That's going to mean that we need the PMT formula. That's not P times M times T, but it's here. When you borrow money, P and R and N are still going to function in the same way, but the payment is going to be P times R on top, and the bottom is going to be 1 minus 1 plus capital R to the negative N. So we do need some stuff to find out to get P, R, and N ready to go into the formula, and we need to place them in the formula and get the proper result for the payment. So let's see what P is. Well, P's got to be figured out with the down payment that we have. We have here, we want to take a 6% down payment, 6 out of 100, and the total is $646,000, and here's the down payment. So D is going to wind up being 6 times $646,000, and then that will be divided by 100, and that'll get me the down payment, which is an essential part of determining how much money is borrowed. We can't just grab P as 646,000. They're not borrowing all of that money. 6% of it is their own money. They're borrowing 94%. 646,000 times 6 and divide by 100. $38,760. And now we need to take that off of the $646,000 to see how much is borrowed. So we subtract that amount from $646,000. So we've got $607,240. That's the amount of principal for the loan, and it's got a dollar sign on it, $607,240. R is called up for next. R is at 6.9%. 6.9. Let's divide by 100 for percent. This is monthly right there, so let's divide by 12. N is 24 years, and we're doing these payments 12 times a year. That's 288. Let's look at the 6.9. 6.9%, so we divide by 100. We divide by 12 to get it to monthly. And what we get is 0.00575. Now let's get to work on this then. PMT payment is equal to principal of 607,240 times straight into the 0.00575. 0.00575 denominator. It's going to be 1 minus 1 plus that 0.00575 power to the negative power of 288. And that's what we need to calculate. The numerator should work out to a terminating decimal. They both terminate, so 607. So good news, we get to multiply these. We should get a terminating decimal, but this one may give me a decimal that runs off screen. So I'll find out what the top is when I go 607,240 times 0.00575 equals 3491.63 to be divided by. In the denominator, I have 1 minus, and then I have 1.00575 to the power of 288 that's negative. And that whole denominator makes for me 0.808191379, and there may be more to it. So what I'd like to do is take the top and divide by as much as I can get for decimals on the bottom. So I'll go ahead and set up that division. It was 3491.63, and then do the division. And I'll come out of here with 4320.300, which is an easy rounding off. $4,320.30 for the payment. And that should wrap it up.